In this example, I want to work through the process of conducting a hypothesis test for means, and keep in mind that I'm going to be looking at conducting a hypothesis test for means that has a large sample, and I'm assuming that a large sample, my sample size is greater than 30. And when I work through a hypothesis test, I want to work through this little acronym that's called phantoms. Now, very quickly, I'll say what each letter stands for. P stands for our parameter statement. So I'm going to make a little statement about the thing that I am going to test. H, it stands for hypotheses. So I'm going to write my null and alternative hypotheses next. A stands for assumptions and conditions. And there's a couple of assumptions and conditions that we need to check or make when we work through this hypothesis test. N stands for name the test. So when I get to that point, I'll name what kind of test this is. T is where the math comes in, and I'm going to find the test statistic. O stands for obtain the p-value. I'm actually going to use p-values to test this claim that is made down here in the example. Sometimes you don't have to use p-values, but for my class I like to use p-values, so I'm going to use them. And then M stands for make a decision, and I'm going to make a decision about the null hypothesis. And then S is state your conclusion. So I'm going to, after I make my decision, I will state my conclusion in complete sentences. So let's take a look at this example. Excuse me. It says, in an advertisement, a pizza shop claims that the delivery time, or the mean delivery time, is less than 30 minutes. A random selection of 36 delivery times has a sample mean of 28.5 minutes and a standard deviation of 3.5 minutes. Is there enough evidence to support the claim at alpha equals 0.01? Now, there's a lot of information in this question, in this setup, and we won't use all of it right at the beginning. We'll use a little bit in each one of these steps in Phantom. So P, I'm going to start off with making my parameter statement, and I want to say this. This is basically a statement about the claim. So I will test the claim. Let me write it that way. I will test the claim that the mean delivery time is less than 30 minutes. Now, there's a key little phrase in this claim, and that key little phrase is less than. That less than tells me how to write and where I should write my null and alternative hypotheses. So now I get to H, and H stands for the hypotheses. So I'm going to write my null and my alternative hypotheses like this. I like to start with the claim. The claim is that the mean time is less than 30 minutes. Well, from one of my previous videos, I may have said something about this, but you should know that the null hypothesis right here will always have an equal sign in it. It'll either be an equal sign, greater than or equal to, or less than or equal to. And in turn, the alternative hypothesis will either have not equal to, less than, or greater than. Well, when I take a look at this sentence, it says I will test the claim that the mean delivery time is less than 30 minutes. First of all, I know I'm dealing with mean, so I'm going to use the symbol mu for population mean because we are testing a parameter. I don't want to use x bar here, I want to use mu. And since this says less than 30 minutes, the claim is saying that the mean is less than 30 minutes. This is where the claim is located. I always like to label whether the claim is in the alternative or the null hypothesis. again, from one of my previous videos, you should know that if the alternative says that that mu, or the mean, is less than 30 minutes, then the null hypothesis has to say that mu is greater than or equal to 30 minutes. These symbols here have to be complements of each other. All right, so now let's continue. The third thing that I want to go to after I have written my parameter statement and then my hypotheses is A, which stands for assumptions and conditions. And when we are working with a hypothesis test for means, the two assumptions and conditions that we need to check are these: the randomization condition, and I also need to check my nearly, some lag in my pen there, the nearly normal condition. Well, let's start off with the randomization condition. This basically is checking to make sure that my sample represents the population. So in the beginning, it tells me that, where is it at? Right here. An advertisement, a pizza shop claims that the mean delivery time is less than 30 minutes. A random selection of 36 delivery times has been collected. So my randomization condition is satisfied because the sample was collected randomly. So that condition has been taken care of. Now the next condition is the nearly normal condition. And one way that you can check this is to take raw data and actually look at a histogram of your raw data and see if it looks nearly normal. Well, I'm not given raw data. So this is where I don't really have a condition, I have an assumption. And so I'm going to say, since I don't have any way to check to see if it's nearly normal, I'm just going to assume that it is. We will assume the data are nearly normal. That's why this particular step is called assumptions and conditions instead of just conditions. Every once in a while, you just have to assume that the condition is true. All right, let's continue. P, H, A. Now I am to N, which is name the test. N stands for name the test. In this case, I am going to conduct a one sample test, and this is a z-test. Because I have a large sample, I'm going to use a z-distribution. And the other thing that I need to look at is the null hypothesis. Since this says mu is greater than or equal to in the null hypothesis, I am conducting a left-tailed test. The way I always try to teach my students is to look at the null hypothesis, right? Let me draw that again, right here. And if the mouth of the null hypothesis opens up to the left, it's a left-tailed test. If it opens up to the right, it's a right-tailed test. If it is an equal to sign, then that's called a two-tailed test. I'm actually going to do another example. One of my other videos gives an example of a two-tailed test. But for this one, I have a left-tailed test. And this is also a z-test because I'm conducting a test for means with a large sample. So here we go. This is a left-tailed z-test. And the other thing that I should say right here is I should talk about alpha, which is the level of significance. So I'll say a left-tailed z-test with alpha equal to 0.01. It tells me in the problem that I want to use alpha equals 0.01 as my level of significance. Make a little side note over here. Alpha is equal to your level. That's called the level of significance. And I'll actually come back to this and talk about how we can use alpha when we get closer to the end. So as we continue through phantom, P-H-A-N, now I get to T, which is the test statistic. Now I'm going to bring in a formula for my test statistic. Here we go. T stands for my test statistic. And where is it at? There it is right there. Let me pull this over so we can see it. This is the formula for my test statistic. Basically what we're going to do is we are going to use a normal model. So a normal model will be a bell-shaped curve like this one. Make this a little bit smaller. I'm going to use a bell-shaped curve, and I am going to use the data that I've collected and the basic statistics to find a test statistic. I'm then going to use this test statistic and label it on my normal model over here in this picture, and I'm going to find the area to the left of that. This is a left-tailed test, so I'm going to find the area to the left and see how that what that probability is. Remember, the area under a normal curve is probability. So I'm going to look at the area under the curve, and that is something called a p-value. But we'll get to that in just one second. Let's find the test statistic. Well, x bar is my sample mean. I go back up here to the top, and my sample mean is 28.5 minutes. I'm going to need that. The other thing that I'm going to need is my standard deviation, which is 3.5 minutes. And then the last thing I'm going to need is my sample size, which is a sample size of 36. So let me plug all of that into my formula for the test statistic, and it'll look like this. Z is my test statistic, and it will be 28.5 minus 30, and 30, if you remember, is mu, and mu comes from my null and alternative hypothesis. Mu always comes from the null and alternative. And I'm going to divide that by the standard deviation, which is 3.5, all over the square root of my sample size, and my sample size was 36. Now, I'm not going to go to my calculator and do the math. I've already done the math ahead of time. And I end up getting here a z-score of negative 2.57. Well, where does that show up on my picture? Well, a z-score of negative 2.57 on my picture is going to be over here in this area. Remember, a z-score in the middle of a normal distribution is always 0. So a z-score of negative 2.57 is going to be somewhere over here. So I will label this z equals negative 2.57. And I have found my test statistic. If I go back to phantoms, the next letter is O. And O stands for obtain the p-value. Obtain the p-value. So how do I get my p-value? Here, I'll write this down. Obtain the p-value. Well, the p-value is basically just the probability. Since this is a left-tailed test, I want to find the area to the left of my z-score, of my test statistic. That's the p-value. Okay, the p-value, let me get an arrow out here. The p-value is the area of this shaded region. Well, I can just use my calculator for that. So let me get my calculator out. And I'm going to find, I'm using a z distribution. So I'm going to go, let's see, second vars. And I go down to number 2, which says normal CDF. So I go normal CDF. And this is, you should know how to find this by now in your calculator, but I'm going to go from negative 99, because that's my left-hand boundary on my shaded region, up to my right-hand boundary, which was negative 2.75. So let's type that in, negative 2 or was it 5.7? Let me go back and look. Yeah, 2.57, excuse me. Negative 2.57. I press enter, And there is the area under the curve. Let me bring this over here so we can see it. And the p-value is equal to 0.005, or approximately 0.005. All right, now I get to M. Okay, phantoms, P-H-A-T, I forgot the N, P-H-A-N-T-O-M, which is make a decision. At this point in time, I want to use my p-value to make a decision. And I always want to compare my p-value to alpha, which is my level of significance. Now, there's two things that come up. I'm going to type this in because it's a little bit easier to type than to write it. But there's two things that you should decide. When you make your decision, one of two things will be true. If your p-value is less than alpha, or your level of significance, then you will reject the null hypothesis. Make this a little bit longer so that you can see it all right there. This is one of the things that can happen. If your p-value is less than alpha, then you will reject the null hypothesis. But what if the other is true? Well, let's type that out. If your p-value is more than alpha, then you will fail to reject the null hypothesis. So those are the two decisions that you need to make. M stands for make a decision, so I'm going to make a decision right now. Well, my p-value was equal to 0.005, and alpha, my level of significance, was 0.01. So my p-value is less than alpha in this case. That means I am going to reject my null hypothesis. So this is how I would say it. Since my p-value is less than alpha, I will reject the null hypothesis. And you can just write it out as a symbol, H naught or H sub 0. I will reject my null hypothesis. Well, that leads us then to the very last step in phantoms. And the last step in phantoms, S, is state your conclusion. Well, I've already said that I'm going to reject the null hypothesis, but what does that mean? Okay, does my evidence support the claim? Because if I look back at the question, I am testing the claim. I am not testing the null hypothesis or the alternative hypothesis. I am testing to see if I have, is there enough evidence to support the claim? Well, think about this. I am going to reject the null hypothesis. Okay? So I am rejecting this thing that I've highlighted. Well, if I am rejecting that, that means that I believe that this is true, the alternative. If I reject the null hypothesis, that means I believe the alternative hypothesis is true, and guess what? The claim is the alternative hypothesis. So is there enough evidence to support the claim? Yes, there is enough evidence to support the claim. I'm rejecting the null, which means I support the alternative, and the claim is the alternative. So yes, there is enough evidence to support the claim that the mean delivery time is less than 30 minutes. So let me type that down here. State your conclusion. There is enough evidence to support the claim that the mean delivery time is less than 30 minutes. Now notice that I said the mean delivery time. Okay? I don't want to just say there's enough evidence to support that the delivery time is less than 30 minutes. This is a test of a mean. So that needs to be a part of your conclusion. Now, this has taken a little bit of time. This is quite a long video, in fact, but these are the steps that you need to follow to conduct a hypothesis test. And specifically, this is for a hypothesis test for means with a large sample. A few of these things will change if you're dealing with means with small samples. In fact, the test statistic is what would change. Or if you were conducting a hypothesis test for proportions, once again, the test statistic would change along with a couple of other things like the null hypothesis and the parameter that you're testing. So I hope that this helps, and I hope that you keep following my videos. Thanks. Bye.